Hello everyone, so we are back again with another lecture on the topic instantaneous center of rotation. Okay, so moving on to the topic, so let's see what is instantaneous center of rotation. Okay, so a rigid body undergoing in plane motion, there always exists a point in the plane of motion at which the velocity is 0 at that particular instant. Okay, so this point is called instantaneous center of rotation or I center. So what is instantaneous center of rotation? Instantaneous center of rotation is a point. There always exists a point in the plane of motion at which the velocity is 0 at that particular instant. So that point is known as the, or that center is known as the instantaneous center of rotation. Okay, so it may or may not lie on the body. If the location of this point is determined, then we can simplify the velocity analysis. To locate the I center, that is instantaneous center of rotation, we use the fact that the velocity of a point on a body is always perpendicular to the position vector from I center to that point. Okay, if the velocity at 2 points A and B are known, I center will lie at the intersection of the perpendiculars to the velocity vectors through A and B. Okay, so here you can see the instantaneous center of a body, the figure of the instantaneous center of a body. Okay, so here you can see it rotates in anti-clockwise direction. Okay, and with a velocity VA. So here you can see the instantaneous center, that is the I center, with A, this is the A velocity, and for point B, this is the VB velocity. Here also you can see for point A, it is the velocity with VA, and here it's the instantaneous center. Okay, it is also rotating with angular velocity omega in anti-clockwise direction. Okay, so here R is equal to VA divided by omega. Okay, so here in this figure you can see the instantaneous center here, located here. So here for point B, you are seeing V velocity for point B, and here you can see is the velocity at point A. Okay, so it is the figure of in I center of a body. So now, if the velocity vectors at A and B are perpendicular to the line AB, I center will lie at the intersection of the line AB with the line joining the extremities of the velocity vectors at A and B. If the velocity vectors are equal and parallel, I center will lie at infinity and the angular velocity is 0. That is pure translation. Okay, so next, number of I center. The number of I center capital N in a mechanism is given by where N is equal to number of links. Okay, so the instantaneous number of I center in a 4-bar mechanism will be given by this, that is 4 into 4 minus 1 by 2 is equal to 6, which is comes out to be the 6. Okay, next is the how to locate I center. Okay, so we must locate the I center and know how to locate the I center. So there are two methods to locate the I center. Number one, by using rules to locate I center by inspection, and number two, by applying our Aronhol-Kennedy theorem. Okay, so here are the rules to locate I center. The center of the pivot is the I center for two links in the pivoted joint. So here in this figure you can see link 1 is the ground link. Okay, link 2 it is rotating in anti-clockwise direction. Okay, so here the I center will be this one, this point you have seen. So this is the I center, it is I with respect to link I1 with respect to link 2. Okay, so it is the I center. So here the I center lies at infinity perpendicular to the path of motion of the slider. So for this figure the eye center lies at infinity, perpendicular to the path of motion of this striker. So here we have seen this is link 1, this is, if we consider this as 2, then here I 1 comma 2 1 2 is at infinity. Okay, so now in this figure, here in pure rolling or in case of no slip between the two links, okay, the eye center will lie at the point of contact between the two links. Okay, so eye center will lie at the point of contact here, you can see. So this is the link 1, okay, and this is the link 2. So if it rotates, okay, so here there will be the contact point. Okay, so this contact point is known as, here in this figure will be the eye center. Okay, so with this we have come to the end of this lecture. Thank you everyone.